Hello, everyone, and welcome to today's webinar. Today, we're going to tell you more about our standalone program, RWIND 2. Especially, we're going to talk about the CFD wind simulation. My name is Jasmin Hartung. I work at Dlubal Software for Marketing and Public Relations, and I'm today's presenter. Today, the presentation will be held by Stefan Hoffmann. For your questions, there will be my colleague Andreas Niemeyer answering them, but I think my two colleagues can now introduce themselves a bit further.
Thank you, Jasmin. So my name is Stefan Hoffmann, and I'm working for Dlubal more than 3 years. And I'm mainly working in the customer support, so I'm answering your mails or phone calls, but I'm also involved in the development of form finding, cutting patterns, and wind simulation. And that's the reason why I'm going to present you today's webinar.
Hello, I'm Andreas Niemeyer. I'm responsible for the product engineering here by Dlubal. And maybe to add, I'm here now since 16 years by Dlubal.
Okay, thank you guys for your introduction. We can now turn off the webcam so that the participants can see the whole screen. So quickly before we'll start with the presentation, I'd like to tell you that you may ask questions during it. For that, you can just use the panel that will be shown on the right side of your screen. Here you can see it. And here you have a field where you can enter your question, and we will answer it during the webinar. If for some reason there are too many questions for us to answer today, no worries, we'll send you an email and answer them as good as we can. And if you just want to watch the webinar for now and ask a question after, that's also no problem. Just send us an email to info@dlubal.com. Okay, now I'll hand over the presentation to Stefan, and we'll begin.
Thank you. Let me choose the correct monitor. Okay.
Okay, great.
So thank you, Jasmin. Everyone should now be able to see my screen. So I want, of course, to start with a brief overview of the content for today's webinar. So on the first part, I have 2 slides. The first chapter is that I want to show you our verification examples area on our website. I'm not sure if you already know about, but we have a lot of content on our website where we show, of course, some frequently asked questions or also knowledge-based articles. We also offer a lot of models to download. You can also later to the webinar find my models to download if you want to double check what I showed, or if you want to use the models as a starting point, or just to get a brief overview on how we would like to model stuff. And close to that, there is also a page or an area where you can find verification examples, also about our standalone program RWIND 2, because a lot of customers are asking us about references and how close you can get to the Eurocode if you are taking care of a wind analysis. And at this area, we show some different shapes. We are also increasing the examples the next months. And there you can get a clue on what settings to do to get maybe close to the Eurocode, even though it should be, of course, higher than the real loads which occur, but at least to argue with any guy who's asking, is this comparable or not? In the next part, which is most likely also linked to a verification example, I'm going to tell you something about our recommended wind tunnel size. So as a first hint, the standard preset wind tunnel size is chosen as small as possible to achieve results in a quite short time. But as according to each finite element analysis, you can think about, is this sufficient enough or not? So it might be that you think about increasing the wind tunnel size if you want to get most likely better results. In the middle, I want, of course, to show you some wind analysis in RWIND 2 Pro. And the main effort for today's webinar is the result evaluation, because I think we skipped it quite a lot in the last webinars, because we showed with the main effort the inputs you can do. And today I want to show you some objects you can use to evaluate the results. The Final parts will be then the wind analysis in RWIND 2 Pro in connection with RFEM 6. So I'm not sure if you use RWIND 2 Pro as a standalone program or you think about it. It can also be directly linked to RFEM 6 and also RStab 9. So you can directly use the forces created from the CFD analysis in our programs, and you do not have to enter them manually. It's a great advantage, and I will also talk something or show something in this matter. Last but not least, I will conclude then my presentation with a prospect. So let's step into the first chapter. As told, the introduction into our verification examples. I have chosen one example. It's the number 308, and it's the Eurocode cylinder shape. And on the left side, you can see a picture of a diagram where the big black line is showing the results the Eurocode offers for us. And then the dotted lines are our wind results with different turbulence intensities. So we, of course, input the wind speed profile according to the standard. And then we differ between the turbulence intensity. So we do not take the standard turbulence intensity given by the standard, but we modify it, as you can see, from 1% to 25%. And as you can see, the highlighted row means that for this special example, for the CF0 value, we would match the best value with the Eurocode by having 15% of turbulence. So if you compare the conservative values of the Eurocode, this would be for this kind of shape, the turbulence intensity you can choose. As told, we also offer this on the website. So you can find it in the area of the downloads and info, and quite below the structural analysis models to download, there is the introductory examples and tutorials. And this offers for our whole programs currently 165 examples. And you can restrict the search, of course, to RWIND, also for RWIND 2 or RWIND 1. And then you can see that we have 15 examples currently. So if you're interested in normal shapes, you can check it. Also a benchmark. Oh, I see it's a bit in German. Well, we fixed it. And you can also, if you're interested in wind comfort analysis, check a verification example of this kind of analysis. Or if we step into the Eurocode cylinder shape, what I have just shown to you, you can see also the dimensions of the shape or of the structure. And if you scroll down, you could directly also download this model if you want to do a verification example, maybe also for a different standard. You do not have to model it by your own again. And also you will find, of course, the turbulence intensities, what we would offer, which then match to the expected value. Okay, let's go to the next chapter. It's the knowledge base article number 1811. It's the recommended wind tunnel size compatible with the Eurocode. And it's most likely for the same verification example of the cylinder we discovered, most likely, of course, by checking the results, that with the normal default wind tunnel size, we are quite higher than the Eurocode would offer it. And this made us think about checking our inputs, of course, and we then adjusted the wind tunnel size, as you can see on the right page. So you see what we would recommend. It's also written in the knowledge base article, but it's quite bigger than the standard size. But as already talked about, our default dimensions are really set as small as possible to keep the calculation times short, because if you use the program once, you have the model standing most likely in the middle of the tunnel or in 1/3 of the tunnel. And this is, of course, a model of surfaces and vortexes. So it's a 2D mesh, which will then be hidden within a computational mesh. So it's a simplified triangle mesh, which is giving over your structure. And this will then interact with a 3D solid mesh, due to the fact that we, of course, have to calculate in our CFD with solids. So putting a wind pressure into the inlet, which then has, of course, go through the whole tunnel and going to the outlet. So let's step once in this knowledge base article. So you can of course find this in the support and learning page, or you just click on the presentation on the link. You can see that if we click on the normal tunnel size, it's most likely that we have in the X direction 10 meter, Y direction 8 meters, and Z direction 4 meters. So it's a small cylinder shape in there. And these results or this size will result in a quick calculation. So if you now compare it to the recommended size, which is at least in the X direction 10 times higher, and you can of course compare the values, what is then the recommended size? You can see that the wind tunnel is enlarged by a lot. So I would propose by doing a quick calculation, you can of course use the default wind tunnel size, which will for this example take 23 minutes. And if you increase it then by roughly 100% the wind tunnel, it will give you most likely a doubled time of calculation. But checking the results compared to the Eurocode, it's now the green dotted line, you can see that these values match quite better. So it's not having a high CP value in the front of the cylinder compared to the Eurocode. So it's of course every time weighting the calculation time against the quality of results. But as you maybe know, you can also do a batch calculation. So you can most likely do quick calculations during the day to get some results, to do a pre-design and let it run overnight maybe if you have the time, and most likely maybe also get better results, what you would expect. So you can have a look into this knowledge base article and check what we propose. I will, as a conclusion later on the prospects, also tell you what is planned by the standard wind tunnel sizes we offer. All right, so these were the two slides I wanted to show at the beginning. And let's now step into my model file. So today's webinar is not about how can I model a silo, which is standing on 4 pillars. I already created the model, since it would then take more than 1 hour if I would model it with you and do a result evaluation. We now have this model. You can as well download it. It is exported from RFEM 6. So I created my main model in RFEM 6. Please always take care that if you usually have a look on the isometric view, our X-axis is going from left to right, and it's most likely a bit confusing, but our wind inlet is going into the global X-axis. It's most likely turned a bit, but if you are aware of it, it's quite easy to know about. So about the rough dimensions, I'm of course using the metric system. You can use the measure distance tool if you want to. You can see that my pillars are most likely 5 meters high and having a spacing of roughly 4.8 meters. And the total height of the structure is roughly 18 meters. And well, it's a silo mentioned to stand on pillars that a truck can drive under it and get filled with the inputs which is inside the silo. But for today's webinar, I did not insert any forces in the RFEM 6 model because for today, it's only about having a look onto the wind analysis. So what I have done is, if I shortly step into RFEM 6, because I have exported it from RFEM 6, you can see that I have modeled with members on over here and surfaces on over here. And if I export my file from RFEM 6 or also RStab 8, I am able to export members. If you would in here use the export function of the IFC file and you would import this into RWIND, you would lose the information about the members, because transforming the member forces back to RFEM 6 is the only effort we do by using the members. If not, it's sufficient enough if they are just surfaces. Just keep it in mind if you are missing the member forces in RWIND, which are only calculated for the primary model. It needs to be exported by one of our programs in order to really receive member forces. I will later on show you the results. Otherwise, you can of course also get a surface pressure if they will be exported as surfaces. What a great advantage of RFEM 6 is, that if you check the model parameters, I have set my location to Germany, Leipzig. There is one office for of Dlubal Software. And I have then chosen the wind profile according to the standard, where this is taking Leipzig, Germany from the GeoZone tool, and it is then directly creating the wind profile according to the standard for me, for my wind velocity, and as well for the turbulence intensity. So I will later on go more into detail in RFEM 6 onto that. But just if you are curious about my simulation parameters, the wind profile can, for RWIND, only be created with the direct link from our programs. Or you can, of course, use your own calculation Excel files or get these data somewhere else. Okay, so let's maybe start with a brief introduction on the settings I did. As already told, this is already calculated. It took roughly 9 minutes on my normal laptop. So if you check, for example, for the mesh inspector of the tools, you can see that the mesh of my introduced object is quite fine. Why is this the case? Maybe if you introduce some IFC file by your own, it might be that this is quite coarse, your mesh. It's also an advantage of RFEM 6 that, as you can see, my RFEM 6 mesh, which is also that fine, is transferred into RWIND. And then it needs, of course, to be split by a half to get these triangles, which are necessary in RWIND 2. So if you're curious that your mesh is not that good, it might be that the mesh from your file you import is quite coarse. So you need to split, of course, your geometry. If it's a stereolite model, for example, it might be that you have to split it already in the cut file. But using RFEM 6, for example, it's quite the mesh we would expect. So let's double click on the wind tunnel. You can see that it's roughly into X direction 80 meters. And if you just click, for example, to adjust it automatically, adjust the model to standing on the ground automatically, you can see that these are the values I just took. So it's for this shape, a quick calculation, but as you maybe can think of, it's a round shape. So it may be necessary, as shown, to increase the wind tunnel size or also to use the transient calculation. It's up to you, but I have chosen the smallest wind tunnel size. Let's sum it up like this. Then if we jump to the simulation parameters, I have chosen for our quick calculation a steady flow. So if you're aware of RWIND 2 Pro, you can of course also calculate the transient flow. And you can see, as already talked about, I have an inlet velocity. The rest is standard values I just left, chosen by the program. And you can see my wind profile is higher, or the wind speed gets higher, the higher I get in my structure. It's of course according to the standard. And if you're sometimes confused how the wind speed is calculated, it depends with the factor, of course, to the inlet velocity. So if you would now switch the inlet velocity, you would of course also switch the final wind speed profile for the graph. So these values most likely belong to each other. So it's no different value, because I already had such a question. And this is the same for the turbulence intensity. It's given by RFEM 6. So I've just used the reference to hand it over. This is also linked to the turbulence intensity you enter in over here. And then you choose, for example, factors, and you can create your diagram with this. You can also check it, of course, as an absolute value if you want to compare it. So I consider the normal turbulence model. I do not consider a surface roughness. It may be done if you want to. And in the info tab, of course, I already have some results of my drag force sum, because I have calculated my file already. Last but not least, for this model, you can also check the program options. There you can, of course, choose the language if you want to. And if you are like me, working with one laptop all over the day, and if you're lazy, you don't want to connect to some other remote computer, you can, of course, choose that your calculation is not using every core of your CPU, but I'm choosing to use only a half of my course, so I have entered the only use for course. So you can choose this option, for example, in the program options. So let me shortly delete the line probes and the point probes, which I will then later on define. And I have already defined some zones. So a zone is most likely a summary of triangles of your model. And the zones, I think they are used quite often. Of course, a good tool to evaluate the results, because you can later on check the zones in a third-party program ParaView if you want to. And also the values for the pressure and the CP values are also exported nowadays in the latest RWIND version into a file where you can evaluate them. They are also shown if you double click on them into an info field where you can gain some interesting data for these parts if you are working with them. And they can be assigned by you. So let me shortly show you the whole mesh. You can see that I have, for this sample file, split my structure into different parts. Please think about adding a zone before you do the calculation, because if you step into the general part, you can see that you can assign a material. You can assign mesh refinements onto a zone, and I have already explained it in the last webinar. You can also define a load factor. So this means that you can increase loads of special areas if you think that in a quick calculation they are underestimating a certain value, because then later on using this and transferring it back to RFEM 6, the loads will of course be increased. So it's a smart tool that you do not have to manually increase the loads for RFEM 6 if you need to increase them or to lower them. So today, I do not want to show the whole part to define a zone. So just as an example, as you can see, you have different tools. So mainly you start with your model and you do not have zones. I can delete them. So I will open the file with results just later on once again. So the first thing you have to do is to click onto zones. Then you have, of course, one general default zone containing every triangle of your model. And then you can create a new zone. You can give it a name if you want to, but I'm just lazy and skip it. So it's only my zone number 2. You can, of course, create more zones if you want. You can choose for the color, which is representing the zone. And then you have to start by using the brush tools or some rhomboid, circle, or polygon tools in order to catch your triangles, which you want to assign for a certain zone. So I usually would start to have a look onto one direction. And for example, if you would use these upper parts to define one zone, you can of course use the brush. So first click on the zone. You can see that then you are in an active tool. We have already selected the brush, and then you can of course just go and mark it with your mouse if you're really having fun painting it like in MS Paint, and you can see then that they are green and assigned to the new zone. Hitting the right mouse button will finalize the option, or you would just click on number 2 and you select the rhomboid, and then you can click once, move over to the right, click a second time, and then every triangle which is fully inside this rectangular, as you can see, I also cut those bottom ones a bit. Only those are assigned to my zone. So it's not like an RFEM 6 going from left to right, everything which is fully inside, or right to bottom left, which is cut just a bit. It's a bit different. Well, it's a standalone program. It's a bit different code. So if you have assigned this to the zone, the next good part is that you could now also choose the sections and only display now zone number 1. As you can see, now my top part is gone. So this will also make it more easy for me to maybe define a next zone now. So if we go to zone 3, you could also choose a polygon and try to define it maybe by certain clicks. Double click at the end. It will then highlight all zones that you can get a graphical overview, but you can of course once again go back and only display zone number 1 and go on, for example, with the brush by clicking on zone 3, mark elements, see if they are correctly assigned, go once back and so on. as told, I will not fully show on how my zones were created. I will just open my file once again. As told, you can of course download it with the zones I assigned. And what is the biggest advantage? I will now show when stepping into the next chapter. So the result evaluation in RWIND 2 Pro. So as told, we now have our one wind direction. Wind is blowing from the inlet to the outlet, interacting with the structure. Please take care, of course. Our model is not moving at all, so it's most likely being infinite stiff. But the volume elements with the CFD open foam calculation is, of course, interacting then with the pressure and our structure and giving us some simulation results. So the first results, which are available on the left side, are mentioned. Let's start with the surface pressure. So if you are curious and only seeing small letters on the right side, and you're not an, let's not call it pro user, but having a lot of clue about the program, I think it is smart if you go into the view, navigator, edit bar options, and just show the icons with the text. And usually then you will have the explanation on the right if you are curious on how to get them. So we now see our pressure forces on the original model. The first information we get after the calculation, it's maybe a bit small, but you can increase it if you want, is the drag force sum on our original model and on our computational mesh. So all in all, we have not only two meshes, we also have the solid mesh in behind. So we have a lot of meshes and they will interact and transfer forces onto each other. But you can compare the original model drag force with the computational model drag force. You can see they are close together. If there is a high gap, it might be that you close openings in RWIND, which is of course possible if you want to ignore inner wind forces. But please keep in mind, if we would, for example, close this part, the wind forces acting on the closed area will not be redistributed onto the members, like thinking of a window. For such a redistribution, you would need, for example, in RFEM 6 load transfer surfaces, because they would then, as expected, having no stiffness and transferring the loads from an opening to the members. So this might be the case, or maybe the mesh is in total a bit coarse, but it's a first hint on what to compare. So the free stream velocity is most likely giving on the highest part of my structure as a comparable value. What you can most likely also activate in the surface pressure is the results on the computational mesh. So you can see that now we have triangles shown. This means that, going back once, I have here my original model handed over from my cut file, so RFEM 6, into the wind tunnel. I did ignore the surface thicknesses. So you can imagine it's one surface without having any thickness in its thickness direction. So it has a front and a back value at the same time. So just keep this in mind, that such a triangle can have two values. Of course, since my structure is closed, we do not have any inner pressure, but we do have a front and a back. This changes once we go into our computational mesh, because this is then a mesh creating triangles, so surrounding our original mesh in order to have triangles for the CFD analysis, what we need. And they do have, of course, now also a front and a back. But mainly you will only have now one value because we have a certain thickness now. Maybe you can see it later on if I show you some forces. So the first thing I would activate is to show the drag force. So you can see that this is most likely a sum of our forces for this wind direction, representing a 3D vector. I think you can experience that if we have such a tall structure, that the most loads should be into the global X direction, depending on the wind speed I will put onto it. So it's quite okay. You can also represent these values for zones if you want to. So you can just click onto sections and then, for example, only choose in here the zone number 2. So don't worry about this shape because it's the, as told, computational mesh. If we would go to the original model for this zone, you can see that it's of course having sharp edges because it's my original model. And you could see that there is a section of roughly 10 kilonewton going on the top part of my structure, and the main X-force should of course go onto the middle half, being the tallest point, and having the highest area of influence, and leaving you with roughly 52 kilonewton. So this is a quite nice value to catch, and it is also given out for zones, also for single models if you want to have a look later on in my 8-part silo. So the next one is the CP coefficient. The color scale will not change because it's usually also bound to the surface pressure, and it's of course higher than 1. As told, it might be that for this structure we should use a bigger wind tunnel, leading to a longer calculation time, but this can of course be done overnight. So these are the 2D value results we get. You can also display 3D results for the pressure field. So let my computer shortly load it. And this will represent, of course, then the solids in the pressure field and their results. So as you maybe can imagine, by reducing the reduced domain to show the full wind tunnel, this is our full wind tunnel with our, let's call it, small model. You can see that the main effort is, of course, to have a small mesh as possible, but it needs, of course, to interact with the boundary of the model. So it needs to be refined around the model. This is done automatically if you want it. And you can still evaluate the full 3D values. I will later on go into the clipper. The next one is the velocity field. Let me once quickly again show only the reduced domain, which I will also talk about, but you most likely do not need the values at the inlet and at the outlet. So we mainly show a reduced domain around the model because this is the point of interest most times. So the velocity field is giving you the velocity of the wind in the unit you chosen, so meter per second in my case. So you can see that, of course, the wind will interact, getting slower, going around the model. If you go to show a certain area, for example, I will show it later on. And it will be a graphically evaluation possible. The next one is the turbulence. I do not want to go into detail on that because this is most likely used by CFD experts, which can do anything with these values. So you may, of course, check the CFD or open foam pages and check what these turbulence values are giving you. Most times you may just check the surface pressure and also graphically what the velocity is doing. So if you don't like the mesh view with the velocity field, you can also use the velocity vectors, which can then display it quite smarter. There are also streamlines, which will show how the wind is flowing around this silo. And as told, I have exported members via RFEM6. So you will get also for our members, which were in original members, some forces. And if you want to know the value, you can go into the view navigator and check on the values. And then you can see that this amount of forces is going into our members. Of course, it's only the member area which is then put into the wind. Okay, so that was most likely a quick summary of our simulation results. And now I want, of course, to show you how you can evaluate the results in RWIND. So the first one we already talked about are the zones. So you can check the zones and they are resultant forces. The next thing is, if you want to do a documentation, RWIND does not offer our own printout report, but you can of course check into the print to clipboard or just print options from RWIND. So you can use, I did already clip, the print preview in order to see some results. You can, of course, also adjust options if you want to have it landscape or something, and then you can copy this. And this can then be put, for example, in Word, because this is not a paint file, so not only a bitmap, but it's a combined scalable vector graphics and a bitmap. And this could later on be copied and also put into the printout report of RFEM 6. Another way would of course be that you use a normal snipping tool. So we most likely use Captura, where you can just make a screenshot and then use these pictures for documentation. Okay, so the next point I want to show you are our three, or most likely three objects to result evaluation. I will not start in a order. I will start with the last one, the point clouds. So a point cloud is an area of points what you can assign graphically, for example, and they can be used for example, to display streamlines from a certain area. So you can choose by displaying the streamlines and that they should only go to your point cloud, number one, for example. And for these streamlines, you can as well also do an animation. So you can see that the wind is flowing and how it is flowing around your structure. And if you want to go crazy, you can of course use the real speed. So this would be the real speed compared to our size of the building. But I would like to prevent to do that. But if you want to do it for a smart documentation, you can do that. Okay, so these point clouds can also be used for particles if you are doing a transient calculation. And you can imagine, of course, that this will most likely represent the smoke you're putting into a real wind tunnel, for example, comparing on how the wind would flow around your building. So you can set these clouds also in 1D and check how the streamlines will divert on our round shape. So going around the structure and also maybe having some turbulence at the end of the structure. So most likely it's, I think, only a smart graphical representation, but of course easy to use. The next one I think used more often is the line probe. So if you want to start with a new line probe and you did not experience a first warning yet, you can see that if you set it graphically, it redirects you to the graph along the line tool. So this one is on this side on over here. So if we once click it, you can see that we now have most likely a clipper plane laying in a plane you decide. So you can choose global axis or also rotate it. I will just use it for Z and define it at a height of 9 meters. And then you are able to create your line. So you would start and picking some points on your circle in order to define a circle. And once you are finished, you click on finish, and you can then gain values as a diagram along our 360 degrees of rotation. You can later on, of course, also adjust the line probe if you hit it too far, like I did. So I'm a bit far over the total length. And the main effort is that you can now save it as a line probe. So if you click on save it as a line probe, you can, of course, think on entering some name for it. I'm also lazy always. And you can double click on it, gather the values. You can choose on what data source of mesh should be used for this. And you can also once again right click on it and display the graph. So displaying it, you can also export it. Of course, if you want to, you can print it. But you can, of course, also use just the values by double clicking on it and show the results on over here. If you want to export them or to Excel or to draw your own graph. The next good point are the point probes. They can be defined by right-clicking and entering a new point probe. So I usually tend to set them graphically. You can, of course, also import some Excel files. And if we now would, for example, check the front, you can just randomly set them and say apply. Of course, they do not look smart now. So I would just point a step back into the probes, double click on them and see, well, okay, I was lazy and did not hit the full correct Y value. So you can later on, of course, also adjust them and say, okay, yes, I think I did one too many. Let's only do 9. Say, okay. And you can see they are now rearranged in a smarter manner. And this can be used, of course, also to do screenshots, for example, in order to document the probes. You can also, once again, double click on it, show the results, export the probes if you want to. You can sum them up in a group, or you can also, once again, hide them or show them. Depends on you what you like to do. So by having a look on our 3D results, for example, let's go into the velocity field. I already shortly talked about the reduced domain. So mainly this is set by a certain factor by us in order to not fully show the whole area, because it's always up to graphic cards and computer capacity, how long this will need to load. So you can quickly edit the reduced domain via this button. So this would leave you by some sliders, so you can increase it, or by just clicking on the slider, you can of course also adjust it manually, hit apply. Then this would edit your reduced domain. You can see they are loaded into the working storage, so it will need to recalculate, but this way you could increase the reduced domain which is shown, or if you're really interested in full values, you just hit once the button and you do not restrict the results to show on the reduced domain, so on the total domain. Having a look on these results, we would now check the clipper, which is most likely a slicer, I think, for surface results. So we can once, what do we want to see? Yeah, I think it's the 3D results. You can quick choose between some global axes by choosing the X, Y, and Z value in order to display some certain cuts. You can move the slicer if you want to have a cut like this. You can also set values over here personally, or you can also check 2D results, then checking for the clipper, activating it, and you can then also show your manipulator in order to move it if you want to move it in a certain direction. So it's up to you what you want to see, of course. So it's most likely cutting your structure, as you can see. If you want to do a certain documentation, you can also save the views later on. All right, so this was mainly the documentation for RWIND 2 Pro. And now in our last part of documentation, I will step back to RFEM 6. So it's the same model I've chosen. As already told, I have chosen my location in Leipzig and I have generated the wind loads for it. So it's the same structure, the same height. Displaying the wind tunnel forces can be done via this function. And as a short summary, what I did insert as mesh settings, because they are most likely also depending to the wind simulation. You can see that I have chosen the normal simplification of my model with a detail of 2. I have the middle optimized member topology. I do not use a terrain, and I keep the wind simulation results. So using this function, you have to take care quite a lot, because it's mainly meant to not have to recalculate the forces if the RFEM mesh is deleted, because of course the RFEM mesh is always linked to the RWIND mesh in some kind of manner in order to redistribute the forces onto the model. This option should most likely only be used if you change a material without taking roughness into account, or change a support condition, because this would not have any influence on the results which may be redistributed on your RFEM model. I do not consider the surface thickness because I think it's not necessary in my case. And I do not run RWIND in the silent mode because I usually like to check what is exported to RWIND before I start the calculation. But if you do it overnight, you should of course run it in the silent mode. The next inputs you have to do is to choose a load case with the analysis type wind simulation. And then you can receive this tab with the wind simulation analysis settings, which you can of course edit. So I use the normal standard settings. Feel free to adjust them if you want to do it, so on. For example, the steady flow, I have changed it to 800 of iterations, but I think it was already done with a bit smaller amount of iterations. And well, you can of course also adjust some other points you want to do in over here. And as already shown, the wind profile is according to the standard. So according to my location, it's automatically created for me. If you do not only want to check for one wind direction, what I only did in this file in order to not have it quite big excessive of data, you can use the wind simulations load wizard. So this would automatically, with the Analyse settings and the profile, create multiple load cases for you for a certain amount of degrees. So if you, for example, would choose 45 degrees, only up to 180 degrees because we have a symmetrical structure, it would create, in this case, 5 load cases for you. What would then automatically contain the rotation, the analysis settings, and the wind profile. So you do not have to go into the load case, copy it, go in here, choose 15 degrees, copy it, choose 30 degrees. Well, it's a smart tool for you, maybe also to compare different wind profiles or different wind simulation analysis settings, creating automatically load cases for you. So once we have results in our main program, of course, it will not be that fast, like only clicking on the eye. It will also take roughly 10 minutes by doing the wind analysis linked to the RWIND model. So at this part, I once want to emphasize that, of course, if you have wind results from RWIND Pro, it is linked to the RFEM file. So if you create your RWIND file standalone, what was not giving out of RFEM 6, you will then need to manually define the loads. If you choose the way like we do to create a model in RFEM 6, or maybe import an IFC file to RFEM 6 and handing this one over to RWIND 2, you can step into the program, for example, via this button. Then the link is there. So these forces will get redistributed onto my model. So it always needs the link. Of course, otherwise it might be a complete totally different mesh and the program will never be able to redistribute the forces from RWIND 2 back to your RFEM model. If you want to do a result evaluation, the first part I would check is the distribution of loads, or maybe also I would, as first part, go into my static analysis and check the total loads into my certain directions. They should be comparable to the loads on the simplified model, no, on the original model, sorry. And then, well, if they match, you should not worry about that the load distribution may be corrupt. But usually I also tend to show the local PZ values load using RWIND. Keep in mind that it might be necessary for graphical representation that all the local Z-axis of your surfaces are showing into one direction. This can be set in RFEM 6. So it looks quite okay, I think. We have a minus value because my Z-axis are pointing outwards out of the silo. So we need to have a pressure because the wind is flowing into left to right. So pressuring the front and maybe having some suction at the end of our surfaces. If you would like now, because we have chosen that we want to keep the results from our wind simulation, you can now also adjust the mesh, for example, making it coarser. Hit OK and apply. So you can see that the middle of my structure is now having a quite coarser mesh. If you maybe have taken care of what the finer mesh is giving you. You now have dilated, of course, the mesh, leading into the dilation of results in RFEM 6. But if you now hit to calculate the load case number 2, it remembers the RWIND data. And even by changing this mesh, you could now calculate it again. And it will redistribute the wind forces now according to the pressure onto your quasar mesh. So maybe it's also a point if you want to compare something, have a look on the load distribution with a quasar mesh. You can, of course, also in RFEM 6 do a documentation by creating a new printout report, where you're able, of course, to choose what you would like to insert into it. So I would just quickly use the preset, not taking care about anything, hit save and show. You can now still in RFEM 6 work in the model, and it will open the printout report for you with the basic stuff what is inside it. So for example, only a summary of the wind profile. So I will only smaller it. You can now, for example, also go into your wind profile and choose to print it into the printout report. You can see the preview. You can adjust stuff if you want to. As already told, I'm too lazy to do that at the moment. And it would also be very much time consuming sometimes, depending on how you would like your printout to be structured. But this is quite an easy way to do so. And you would then have the picture inside. If you, for example, would like to have some pictures from RWIND, you can quickly also go via calculate to open it in RWIND. And then as told, there are two options. You could now use the clipboard and then the way over Word to enter it into the printout report, or you just use quickly some screenshot tools, making a picture of it, copying this, going back to your printout report, go to insert an image from a clipboard, or you save them also as single files, giving it a title, entering it into the printout report, and there you go. We have our image from the clipboard inside it. You can also do some other clips if you want to. So just showing once the way we are Word, since if you remember, the clipboard is doing some Windows meta file, giving us also some text. You can also do that by file, print to clipboard once again, opening it like this picture, copy paste it inside it. It's still loading, so it was still the old preview. Okay. So you can see now the streamlines, and you could also copy this directly out of Word into our printout report, into the clipboard. And then you can see that it's a bit different having this black scale bottom down, because this is up to the meta file, which what you may need to adjust then, depending on what you would like to clip. I personally would usually do it in this way because I know what I see, and it is, I think, giving quite well into the printout report. Okay, so let's close it, close Word. And keep in mind, if you have RWIND opened from RFEM 6, RFEM 6 is, since it's linked to its result, in a sleepy mode. So you, of course, have to close RWIND with this model if you want to go back to RFEM 6. So you can then later on, once again, go back to RFEM 6. What I skipped in my result evaluation, and what I, of course, want to mention once in RWIND, is that you, of course, also get an overview about the convergence diagram, or what we call it a residual diagram. So going into the program, you also have these simulation results giving you the residuals that you can get a closer look on how the drag force is acting on the total model and how the surface pressure is acting. So I reached in my calculation after roughly 400 iterations, my pressure residual. So the calculation was stopped because in my simulation parameters, I have chosen that I want to have minimum 300. So even if the pressure would drop earlier below my defined target value, it would still do 300 calculations. And if it would never reach my target value, it would at least do 800, most likely giving you a warning if it was not reached. Okay, so last but not least, I will step back to the prospect to conclude my presentation and today's webinar from my part. So the prospect, just as some remarks, not everything what is planned for the future, but 3 points or 3 bullets I want to talk about. We, of course, plan to add more verification examples, giving you the chance to check what inputs might be necessary, and maybe also to argue if the results can be taken or not. it's of course highly discussed if the Eurocode is now the standard to be used, or if you can of course also use CFD analysis results. I mainly think that if you are able to compare your digital wind tunnel with real values in order to see that your model and the inputs are matching most likely a real situation, so like fine-tuning your CFD or FE model to the correct physics, I think you can use the wind loads from RWIND because then you can think about that the results and inputs are correct. But this is always, I think, up to your standard and the guy who's maybe also having a look on your file and calculations. The next bullet point is the preset wind tunnel dimensions. I have summed it up as fast and inaccurate versus slow and accurate. It's really just as a bullet. It does not mean that the fast and small wind tunnel leads to inaccurate results, but mainly the finer the mesh, most likely depending on singularities, the more accurate your results. We would like to offer there more options that you maybe have a quicker set of your wind tunnel and you do not have to think to factorize the wind tunnel by your own. And last but not least, the suppression of warnings and errors in a batch calculation. So having it run overnight via the project manager by having a view on different wind directions. Sometimes you would get such a warning if the residual was not reached, that they might be ignored later on, summed up in a list and to be given to you in order to evaluate. But you do not have to watch the calculation the whole time in order to press OK, just that the batch calculation will not stop. Okay, so far so good. I would like to hand back to Yasmin now. Thank you for your attendance, and Yasmin will have the last minutes of today's webinar.
Okay, great. I'll take over again. Just 1 second. Okay, great. So if you're interested in purchasing RWIND 2 or have any interest in our other programs or add-ons, or just want to get to know more about them, you can always just book a free online appointment with one of our sales experts. Therefore, you can use the link here in the PowerPoint or scan this QR code with your phone. And yeah, you can book a product demonstration or just get an offer, which is of course non-committal. Okay, before I want to end this webinar, I'm going to show you where you'll find the recording of today's webinar. Therefore, we go to our website, dlubal.com. You go to News and Events, Webinars, loading. So here you can find today's webinars. Here you can also find the upcoming one. Just note that this time it's on a Wednesday and it's from 10 to 11 a.m. So now you can go to today's webinar. Around here, you'll see the recording tomorrow. Here you can find the presentation slides that we used. And here you can also find the models that were used in today's webinar. Great. So lastly, I'd like to thank Stefan for his nice presentation. I'd like to thank Andreas for answering all the questions. And of course, I'd like to thank all the participants for attending today and for their interest in our program. And yeah, I'd like to thank you again and have a nice rest of the week. Maybe if you have 2 more minutes after this webinar, you can answer some questions in a short survey we prepared. I'd just like to note that 1 is the lowest rating and 5 the highest. Thank you very much. Goodbye.